Welcome to Cosmic Discoveries, your gateway to the most fascinating and groundbreaking revelations from the cosmos. Today, we are about to embark on an extraordinary journey, exploring the vast frontiers of space through the eyes of the James Webb Space Telescope. This marvel of modern technology has opened a new chapter in our quest to understand the universe, and its discoveries are reshaping our understanding of everything from the smallest celestial bodies in our solar system to the most distant and mysterious corners of the cosmos. Prepare to be amazed as we delve into the profound implications of these findings, shedding light on the secrets of Pluto, the nature of exoplanets, and the very fabric of the universe itself. Pluto, the dwarf planet that has captivated scientists and space enthusiasts alike for decades, is once again at the forefront of astronomical research. Since its discovery by Clyde Tombaugh in 1930, Pluto has been a symbol of the outer reaches of our solar system, a mysterious world on the edge of the known universe. However, with the advent of the James Webb Space Telescope, our understanding of this distant dwarf planet has taken a giant leap forward. One of the most astonishing revelations from the JWST is the discovery of heat signatures on Pluto's surface. At first glance, this might not seem like a big deal. After all, we live on a planet with a warm, dynamic surface. But Pluto is no Earth. Located in the frigid Kuiper Belt, far from the warmth of the sun, Pluto's surface temperatures hover around a bone-chilling minus 375 degrees Fahrenheit. It's a world where ice reigns supreme, and any source of heat is not just unexpected, it's downright puzzling. So what could be causing these heat signatures? The JWST's advanced infrared sensors have detected areas on Pluto's surface that are emitting more heat than the surrounding regions. This has led scientists to speculate that Pluto may have experienced a massive impact event in its recent geological history. Imagine a comet or asteroid hurtling through space, colliding with Pluto, and unleashing an immense amount of energy. The resulting impact would have generated enough heat to melt the surface ice, leaving behind areas that are warmer than the surrounding landscape. But the implications go beyond just a simple impact. This event may have triggered widespread geological activity, reshaping Pluto's surface in ways we are only beginning to understand. The idea that Pluto, a dwarf planet, a tiny speck in the vastness of space, could have experienced such a cataclysmic event is mind-boggling. It challenges our assumptions about the kinds of processes that can occur on small, distant worlds, and it raises new questions about the history of our solar system. The JWST has also provided new insights into Pluto's tectonic activity. Previously, scientists believed that Pluto was geologically dead, a frozen relic of the early solar system, preserved in ice for billions of years. But the latest observations from the JWST suggest otherwise. There is evidence to suggest that Pluto has a global tectonic system, one that has caused significant shifts in its crust over time. This is not just a minor geological process. We're talking about the kind of tectonic activity that could cause entire regions of Pluto to move, reshape, and reorient. One of the most intriguing features of Pluto is Sputnik Planitia, a vast heart-shaped basin on its surface. Sputnik Planitia is not just a pretty pattern, it's a window into Pluto's dynamic history. On Pluto, the accumulation of nitrogen ice in Sputnik Planitia may have been enough to tip the entire dwarf planet, reorienting it relative to its orbit around the sun. But what if this process is still ongoing? Could Pluto still be in the midst of a slow, dramatic transformation, its surface and orientation changing over time? The idea that a dwarf planet could be undergoing such significant changes is both thrilling and humbling. It forces us to reconsider what we thought we knew about the outer solar system and the processes that shape these distant worlds. As if these discoveries weren't enough, the JWST has also provided new data on Pluto's atmosphere. Pluto's atmosphere is incredibly thin, composed primarily of nitrogen, with traces of methane and carbon monoxide. During its closest approach to Pluto in 2015, NASA's New Horizons mission provided us with our first detailed look at this tenuous atmosphere, revealing that it extends far beyond Pluto's surface, forming a hazy halo around the dwarf planet. However, the JWST's observations have revealed something unexpected. Pluto's atmosphere is shrinking. Over the past few years, scientists have noticed a significant decrease in the density of Pluto's atmosphere. This is likely due to Pluto's elliptical orbit around the Sun. As Pluto moves further away from the Sun, its atmosphere begins to freeze and collapse, falling back onto the surface as frost. This process is not unique to Pluto. It's something we've observed on other bodies in the solar system, like Triton, Neptune's largest moon. But seeing it happen on Pluto in real time is a powerful reminder of how dynamic and ever-changing even the most distant worlds can be. These findings have profound implications for our understanding of the outer solar system. They suggest that Pluto, and possibly other objects in the Kuiper Belt, are far more active than we previously thought. Instead of being static, frozen relics of the early solar system, these distant worlds may be undergoing complex geological and atmospheric processes, driven by their interactions with the Sun and other celestial bodies. This challenges our assumptions about the nature of the solar system and opens up new avenues for research, as scientists seek to understand the forces shaping these distant worlds. But Pluto is just the beginning. The James Webb Space Telescope is also shedding light on other mysterious objects in the Kuiper Belt, a vast region of space beyond Neptune, filled with icy bodies that hold clues to the formation of the solar system. One such object is Arrokoth, a small, flattened world that was visited by the New Horizons spacecraft after its historic flyby of Pluto. Arrokoth, with its strange, two-lobed shape, is the most primitive object ever studied, a remnant from the early days of the solar system. It's a window into the past, providing us with a glimpse of the building blocks that eventually coalesced to form the planets and moons we see today. Arrokoth's unique shape has puzzled scientists since its discovery. How did this object form? And what does it tell us about the processes that shaped the early solar system? The JWST is helping to answer these questions, providing new data on Arrokoth's composition and structure. This data suggests that Arrokoth may have formed through a gentle, low-speed collision between two smaller bodies, which slowly merged to create the belobed shape we see today. This process, known as accretion, is thought to be how many of the objects in the Kuiper Belt formed, slowly coming together over millions of years to create the diverse array of bodies we observe today. The JWST's observations of Arrokoth are not just about understanding a single object, they're about piecing together the story of the solar system's formation. By studying these ancient, icy bodies, scientists can learn more about the conditions that existed in the early solar system and how those conditions led to the formation of the planets and moons we see today. It's a fascinating journey into the past, one that is helping to unlock the secrets of our cosmic origins. But the James Webb Space Telescope's reach extends far beyond the confines of our solar system. It's peering into the atmospheres of distant exoplanets, worlds that orbit stars far beyond our own sun. These planets, many of which are located in the so-called habitable zone, where conditions might be right for liquid water, are some of the most intriguing targets for astronomers. The search for life beyond Earth has long been one of the driving forces behind space exploration, and the JWST is providing new tools to pursue that quest. One of the most astonishing discoveries from the JWST comes from its observations of VHS 1256b, a giant exoplanet located 40 light-years away. VHS 1256b is unlike any planet in our solar system. It's a gas giant several times the mass of Jupiter, with a weather system that defies the imagination. The JWST has detected silicate clouds in the planet's atmosphere, clouds made of tiny particles of rock and glass, swirling in storms that could dwarf anything we see on Earth. But what makes VHS 1256b truly extraordinary is the presence of molten rock in its atmosphere. Imagine a world where storms carry not just rain, but molten droplets of rock, where the winds whip through clouds of vaporized minerals. This is a planet that challenges our understanding of what is possible in the universe, a place where the weather is as alien as the landscape. These observations are not just a curiosity, they're a window into the diversity of planetary systems in the universe. By studying the atmospheres of distant exoplanets, scientists can learn more about the conditions that lead to the formation of planets and the potential for life beyond our solar system. The discovery of silicate clouds and molten rock in the atmosphere of VHS 1256b is a reminder that the universe is far more complex and varied than we ever imagined. The JWST's advanced instruments, including its mid-infrared instrument, MIRI, and near-infrared spectrometer, NIRSpec, are allowing us to study the composition and behavior of exoplanetary atmospheres in unprecedented detail. By analyzing the light that passes through these distant atmospheres, scientists can determine the presence of various gases, including those that might indicate the potential for life. One of the most intriguing questions in astronomy is the fate of our own galaxy, the Milky Way. The Milky Way is on a collision course with the Andromeda Galaxy, the closest spiral galaxy to our own. This collision, which will occur in about 4.5 billion years, will have a profound impact on both galaxies, reshaping them into a single, massive elliptical galaxy. The JWST is providing new data on the dynamics of galaxy collisions, helping scientists to understand the processes that will shape the future of our universe. But what does all of this mean for us here on Earth? The discoveries of the James Webb Space Telescope are not just about understanding the universe, they're about understanding our place in it. They remind us that we are part of a vast, interconnected cosmos, one that is constantly changing and evolving. They challenge our assumptions about what is possible, and they inspire us to keep pushing the boundaries of our knowledge. The exploration of space is not just about answering scientific questions. It's about expanding our horizons, both literally and figuratively. It's about looking beyond our own planet, beyond our own solar system, to the vast expanse of the universe, and asking the big questions. Where did we come from? Are we alone? What is the nature of the universe? The James Webb Space Telescope is helping us to answer these questions, one discovery at a time. As we continue to explore the cosmos with the James Webb Space Telescope, the possibilities are endless. Each new finding is a piece of a much larger puzzle, one that spans billions of years and countless light years. From the mysterious history of Pluto to the chaotic weather on distant exoplanets, from the earliest galaxies to the future of our own Milky Way, the JWST is opening our eyes to the wonders of the universe in ways we never imagined possible. But the adventure is just beginning. The James Webb Space Telescope is set to continue its mission for years to come, providing us with a steady stream of discoveries that will change our understanding of the universe. What mysteries will it uncover next? Will we find signs of life on distant worlds? Will we unlock the secrets of dark matter and dark energy? The answers are out there, waiting to be discovered. Thank you for joining us on this incredible journey through the cosmos. Don't forget to like, comment, and subscribe to stay updated on all the latest discoveries. Let's continue to explore the unknown together, one revelation at a time. Keep looking up because the universe has so much more to reveal.